In class example 2.31, we'll use the factor theorem to confirm some factors of a polynomial. Here we're given p of x equals 3 times x to the 4 minus 4 times x cubed minus 19x squared plus 8x plus 12. We're asked to use the factor theorem to show that x minus 1 is a factor of p of x. Well, let's just take a second to be grateful for the factor theorem, because the thought of walking through the steps of long division here makes me feel tired and anxious. Not because it won't work, and not because it's a great strategy, but you know, it's just a little bit excessive, isn't it? Instead, let's say if x minus 1 is a factor of p of x, then evaluating the polynomial for an input value of 1 should generate an output value of 0. Well, we replace all the x's with 1 and find that it does indeed turn out to be a 0. This confirms there is no remainder, or a remainder of 0, and means that x minus 1 is a factor of p of x. If our given binomial has a coefficient other than 1 in front of the x, well, we have to determine the 0 of that, and here we find it to be a fraction, negative 2/3. A reminder, you could find this by writing 3x plus 2 equals 0 and then isolating x. Here, just like in the first case, we will replace all of the x's with negative 2/3. We evaluate every term, add them up, and again, find a remainder of 0. So we know that 3x plus 2 is also a factor of p of x. When we check if x plus 1 is a factor, which we do by evaluating for p of negative 1, we find a remainder of negative 8. The remainder theorem tells us that this is the height of the graph. But when we're talking about the factor theorem, all we really care about is it a 0 or is it not a 0? And since it's not a 0, it's enough for us to say that x plus 1 is not a factor. Point 1. Here we see the graph of this quartic function, and we see two zeros that correspond to the factors we examined. We also see that there are two more factors. That's because this is a degree 4, so it can have at most 4 x-intercepts. We will not find them here, but if we did factor out the x minus 1 and 3x plus 2 using long division or synthetic division from the original polynomial, we would have a remaining quotient that would be quadratic, so degree 2, and we could factor that to find the remaining 2. Otherwise, we could play some guess and check games, trying values until we found other factors which gave a remainder of 0.